Okay, let's look at number one on the review. Number one has a couple different parts, but what we need to look at is we're using these three functions, g, h, and k, and they've given us a function below, and we have to state what the combination is between these three to make what they're asking about. So is this g of h? Is it k inverse of g? Are they both inverse? And whatever, we'll work from there, okay? So a is 1 over x squared minus 1 plus 5. So looking at the original 3, well, there's only one that has a fraction, so we're going to be using that. And it also has an x squared in it, so that's also h. And it looks like the fraction is the outer function, and the x squared minus 1 is inside. So that would mean g comes first and then h. And you can write that as gh, or you can write that as gh of x. Either way, and that's all that's looking for. So let's look at b. b is 2 over x plus 5 plus 1. So now we have a 2, beginning in a 2, we have a 1, and we have a fraction. So again, we're going to use the fraction. But now we have a 2 and we just have x. We don't have any squared. So that's most likely going to be the last one. So it looks like we would get this function b if we plugged the fraction into 2x plus 1. So that means that the outer function is k and the inner function is g. So remember, or you could write that as kg of x. Okay. The next one, we have c. So we have this square root. So to figure out where that square root is coming from, we have a 2 times the x and a plus 2. So if we look up here, none of our functions actually have a square root when we first look at them. So there is a function that has a squared. That's the closest that I come to that function. Well, the opposite of squared is a square root. So that means I'm probably going to use h inverse because that's opposite, h opposite. The inverse of that would be adding 1 and then taking the square root. So h inverse is actually the square root of x plus 1. Okay, so that is going to be, that's my outside function. So h inverse is actually going to be the first one that I see. And then on the inside, I don't have any other squares or fractions. So I'm going to plug in the k to that. And it's not divided. It looks like it's just 2x plus 1. So that's plugging k into h inverse. Because if we did have the square root of x plus 1 and we plugged in 2x plus 1, well, that would give us the square root of 2x plus 2. And that's what we have. So remember, or we can write this as h inverse of k of x. And then this last one. So let's look at part D. We have 4x plus 3. So we have no fractions. We have no squared or square root. So that leaves us with this last one. So let's see if we can combine 2x plus 1. Well, 4x would mean we had in there, we had a 2 times 2 somewhere, and then a 3, we would have to add 1 a couple times. So let's try this. What if we had 2x plus 1, and we plugged that in to 2x plus 1? Well, we distribute that. There's a 4x. Here's a plus 2 plus 1, and that gives us a plus 3. So here's 4x plus 3. What did we do? We used the last function and we plugged it into itself. So there are quite a few ways we can write that. We can say k of k, or we can write k2, which means that we can also write k of x, or k2 of x. Those are all our possible answers for that one. They all mean the same thing, it's just in a different form. And that's all you need to do for these first 4 problems. So it's really just recognizing the pattern and figuring out how it fits.